The information economy has arrived. The world is teeming with innovation as new business models reinvent every industry. Inside Analysis is your source of information and insight about how to make the most of this exciting new era. Learn more at InsideAnalysis.com.
InsideAnalysis.com.
And now, here's your host, Eric Kavanagh.
Yes, sir.
All right, ladies and gentlemen, welcome back once again to the only coast-to-coast radio show in the U.S. of A that's all about the information economy. It's time for Inside Analysis. Yours truly, Eric Kavanagh here. And what a fun topic today, folks, living on the edge. Of course, you remember that great song, Living on the Edge. Yes, a computing revolution, I should say. So what is the edge? We're going to talk to a couple experts today to find out. We've got Peter Norwood online from Pratexo and a guy named Loren from a company called DartPoints, both in Texas. So excited about that. One of my favorite states, I have to say. I lived in Austin on and off for a number of years, in Wimberley in the Hill Country. So I love Texas, can-do attitude. Not surprised we got some IoT innovation going on down there. So real quick, what is the edge? The edge is basically any of the various devices that are out in the field right now. Your phone is part of the edge. A sensor can be part of the edge. A router could be part of the edge. In a shopping mall, for example, any number of things can be part of the edge. That the edge is where you collect information and sometimes deliver information. So like I say, a point of sale or on an oil rig, for example, you could have lots of sensors and lots of devices. Those are all part of the edge. So there are lots of questions that come up in terms of how to leverage edge computing. What kind of compute do you want to do on the edge? How much data do you want to pull back to your data center or to the cloud, for example, to execute, to analyze, to run some algorithms on? There are lots of ways you can do this, and that is a blessing and a curse because it could be quite a conundrum to figure out exactly how to orchestrate the different component parts to make something happen. And of course, we'll talk about some use cases: when, why, where, how do you use these technologies? So let's go ahead and dive right in. I'll start with Peter Norwood from Pratexo. Peter, tell us a bit about yourself and your company and how you are enabling edge computing.
Yeah, thanks, Eric. So yes, I'm Peter Norwood. I'm Chief Product Officer of Pratexo. We're based in Austin, Texas, but we're global. We have offices in Sweden and throughout the United States, and we've been in operation for a couple of years. I came to Pratexo last year. I spent the past 7 years at Google. I was the site lead for the Austin, Texas office that grew to a couple thousand folks. And I left last year and I got very excited about the opportunities in edge computing and IoT. There are just so many very interesting use cases that are very useful to the world, a lot of sustainability use cases. But it seems like a new computing paradigm. We're now no longer talking about centralizing things in an on-premises environment or even operating all of our computing in the cloud. We're talking about taking a lot of the capabilities of the cloud and pushing them out to where the devices are. We're faced with a world now where we've got millions of devices that have intelligence built into them, whether it's in the manufacturing industry, shipping industry, smart cities, automobiles. We have lots of smart devices out in the world, and it becomes very difficult to move all of the data that we're collecting there up to the cloud to do the processing. The goal is really to push the algorithm out to the petabyte rather than the petabyte up to the algorithm. And that's what edge computing is all about, is how do we push the computing infrastructure in this new computing paradigm out to the edge. And we call it the far edge. We want it to run not just in local cities, but actually right next to where all the sensors are, the most efficient way. So it becomes a very large scale distributed computing problem that you have to solve, which has new challenges. And Pratexo's mission is to make it easy to design and deploy multi-tier complex edge computing networks to solve these problems. We are trying to solve the problem that 75% of edge computing projects fail, and they fail because it's just too complicated for people. They have too many different partners they need to get. They need to work with sensor partners, with hardware device partners. They need to work with application developers, AI modeling companies. there's a lot of people that need to get together to work on this, and it becomes very difficult because it's such a large-scale distributed problem.
Right.
So that's our mission, is to make it easy for companies to accelerate their projects by simplifying the process.
Yeah, that's great stuff. And I get excited thinking about these sort of waves of innovation that we get in the industry. And I remember, I've been tracking it now for 30 years, technically. And I remember when there was an exodus from Yahoo in the early aughts, like in 2000, 2001, 2002, lots of folks left Yahoo and went and started all these different companies, a lot of these big data companies that grew to huge, amazing heights, all started from Yahoo engineers and other executives who left there and just started their own thing. And now we're seeing the next phase of that, where people leave Google, they leave Facebook, they leave LinkedIn. And what's cool is that you folks tackled problems at a scale, a computational scale that has never been done before. And so what you learn is that there are problems that you never expected. You didn't even know what the problem looked like at the time, and you had to kind of hack away and figure out how to make these things hum. And now you're able to take that knowledge and that wherewithal to new challenges and new companies. And I just find that fascinating, because you can't get that sort of experience just by thinking about it or reading things. You kind of have to immerse yourself to know what the challenges look like, and then to be able to build out platforms and frameworks for the future. Is that about right?
That is exactly right. So we want to take all of the things that we've learned in cloud computing, for example, the ability to have a job that can scale easily. We want to have failures of systems not stop the entire process from working.
Right.
So we want resilient, scalable systems. And we want to take that kind of thinking, but repurpose it to the far edge. Mm-hmm. And so taking clouds and turning them into micro clouds that run into the far edge. And that's really the new paradigm.
That's interesting. And especially with IoT, because there are lots of different challenges with Internet of Things. And one of them is that you have so many devices that are supposed to be sending information, and sometimes their networks go down, sometimes they lose power. And so you have to be able to kind of normalize and anticipate that and know how to read that, to understand, is this a problem or is this just what normally happens? I think that's a big part of the nut to crack, right?
That's right. There are technologies, cloud technologies like Kubernetes, and now there are new versions like micro Kubernetes that are designed to run at the edge, and they can even run without an internet connection. So they can have a local network at the edge and only periodically send data up to the cloud to be processed by the company in some ROI dashboards. And that's really a new computing paradigm, but we have to stand on the shoulders of people that have built the cloud technology in the past and leverage those learnings to be able to be successful.
Yeah, and micro Kubernetes. I'm just learning about this now, folks. Exciting stuff. I've been tracking Kubernetes for a while. It's absolutely fascinating. And I heard a theory actually about why Kubernetes won versus Docker and some of the other, like Mesos. There's some other opportunities out there, some other folks tackling that. And again, the explanation I heard was that Google was very clever in making it free for the developers, because a lot of times developers don't really have budget to pay for stuff, so they just want to roll their own. That's what they do for a living, is they develop stuff. And so that was the secret ingredient in the strategy. And pretty much everyone agrees now that Kubernetes won. I kind of see it evolving towards a sort of de facto operating system of the cloud. But good, hard, excellent Linux developers will give me a hard time about that. But do you kind of see it that way? Is it's sort of expanding to become a sort of de facto OS for the cloud?
Yes, and I think that the movement is towards open source technologies in general. Mm-hmm. People want to use open source technologies and design an entire network out of them, and rather than using some sort of proprietary, being locked into a proprietary system. That means you can run on top of multiple types of hardware, and there's just a plethora of different types of hardware devices that we're talking about managing at the edge.
That's right.
We need to work with whatever is out there. So being able to put together, to architect a system with lots of different open source technologies, and doing complex things like allowing for failover and for scalability at the edge is the new challenge. And so what Pratexo does is we provide a design studio that allows an architect to put together all these open source components easily from templates of known reference architectures for each industry, and then deploy that through a push button deployment and get it running at the edge and then manage it continuously. And then they can work with, and we target that towards system integrators that are the ones that are in the middle, because I mentioned there's so many different partners that need to work together. So if the system integrator has a tool like this, then they can work on behalf of many different companies in the same industry and make it a repeatable process that works very quickly.
Yeah, that makes a mountain of sense. Because again, I've been watching this for a while now. And to your point, the number of devices is mind-blowing. The number of permutations of weaving those different devices together in a stack, like building out these stacks, is, it's exponential, right? I mean, there's so many different ways you can do it. And the other thing too that's very exciting to me is now I think we're finally seeing real synergy in what we've called historically IT versus OT, right? Information technology versus operations technology, like in manufacturing, for example, when you're dealing with machines, building machines, all that stuff that's in the OT world. It has its own way of thinking and operating. A lot of that stuff goes way back too. I mean, that some of these factories have been using cool technology for 40 years, right? Or longer. So being able to integrate those two worlds in a meaningful way where you can see what's happening, understand the possibilities, and then build out your solution, that's really powerful stuff, right?
Yeah, I mean, we're talking about a lot of obscure protocols that these sensors talk over: LoRaWAN, BACnet, Modbus, things that were new to me even when I joined into this space. So you need to connect to a lot of existing technology that's out there, that's been out there for a while, and learn how to use it easily. And some of the use cases are just fascinating too. You mentioned the manufacturing industry. We work with cement mixing companies that have vibration sensors on them. Right. And they're trying to make sure that they understand when they're going to break so that they can order parts for them before it happens so they can continue their operations. We're working with power companies that are worried about the power surges that happen at certain times and trying to level the powering. So they have to monitor the power in transformer stations. We even work with windmills where they're tracking birds so they make sure that they don't kill too many birds. So there's cameras doing real-time image recognition. And trying to understand the impact to the environment. So the number of use cases at the edge is higher than any other field I've ever seen, because we're talking about the real world and all the sensors in it.
Yeah, and we can finally see all of that, right? I mean, I think Google, let's face it, has done a tremendous amount to kind of push the ball downfield on this front. Just Google Maps and Google Street View, for example. I mean, if you want to really drive home the significance of IoT in general, just think about Google Street View, that now you can look up almost anyone's house in the United States, and there they are, there's the house from some period in time, right? To be able to track though all these different devices in all these different places, it's really quite remarkable. And I think we're probably going to be going through this phase in the next couple of years of just really digesting what we can see and understand, because hitherto it was all either projections or estimates or presumptions about things, but now we have the raw data and we can look at the data and try to better understand the magnitude and the diversity of our world, right?
Yeah, and you want to keep the data, we talk about the edge and the far edge. You're collecting so much data, it's very expensive to pull it up to a central cloud. You also have security reasons. You mentioned a lot of data that we're collecting. A lot of times you don't want that data to leave the area. You only want the analysis done there and significant events to be sent up to the cloud. That protects people's privacy. Also, if we're managing everything at the edge, we're managing the electrical grid and the infrastructure of the country. We don't want people hacking into it easily. So there's a secure boundary between the internet and the edge that has to be established. So those are some new challenges that are posed by the type of edge computing architectures we need to put in place.
Yeah, and I'm glad you brought up energy too, because these systems that we use to power our cities, obviously we're trying to get much better information on that in this new world, let's call it, of knowledge, of awareness. We now can understand and really gauge the power usage, where it's coming from, where it's going. I mean, a lot of that stuff has been black magic for a lot of folks for a long, long time. And again, we're starting to really crack the code to penetrate and understand what you could do. Think about smart cities, for example, with smart stoplights and smart lighting just in general. I mean, I came from the era of the very, very dumb stoplights. They didn't care if you were there. If 100 cars are in this direction waiting for a red light for 2 minutes and no cars have been going that way for an hour, who cares? The light didn't care. Now they do, right? We started with the plates underground, but now you got all these cameras that could just sense things. You don't have to put plates under the ground anymore. You can just have cameras that have sensors, right? It's amazing. Just the sensors on bots and the sensors on drones, for example. It's just astonishing what you can accomplish these days, right?
Yeah. The amount of data that's out there that is now dark data that people are just not even able to access is tremendous. And there's a tremendous built up pressure for companies to leverage that dark data and do something useful with it to increase their productivity, to do preventative maintenance, to fulfill their sustainability obligations.
Yeah.
And so edge computing is the answer. What's challenging is, how you put all that together, design it, deploy it, and manage it continuously.
Yeah. That's right. I mean, before our break, I'll just throw out a fantastic case study of a guy I've known for years. He was at Alteryx for a long time, George Matthew. Then he went on to a drone company. And they have drones that can fly over, you think like industrial complexes where you have like just giant mountains of sulfur and salt and phosphates or whatever. And the drone can fly over this thing and then give you an astonishingly accurate estimate of how much there is. Whereas before you were kind of looking at it, go, I don't know, is that 10 tons? Is it 15 tons? They can get the exact number. Just think about how powerful that is for planning, for valuation, for insurance purposes, for all kinds of reasons. Now, the data, you're not guessing so much. Real quick, like 30 seconds. What do you think?
Yeah, that reminds me so much of I mentioned the use case with the windmills where we're helping cameras do image recognition. The alternative is having someone in a boat out there, literally counting, looking for birds periodically and then extrapolating from that.
That's right.
Or at the power company, they send people out to listen to the machines to see if they're going to break,
right,
rather than doing something in real time with a microphone. So yeah, you're spot on.
Yeah, that's fascinating. And you think about these power complexes and things. Now you can have so many different sensors. And, to the point here, you can actually tell just by the vibrations on these things. Once you get a baseline, once you pull in all the information and run the statistics on it, run the algorithms, you learn to understand what is a steady state, what is the normal state, how is it supposed to be? And when it starts varying outside of that, you have something to look at. And wow, we'll talk about that maybe in the next segment during the roundtable, how it improves morale for everyone involved. We'll be right back. You're listening to Inside Analysis.
Welcome back to Inside Analysis. Here's your host, Eric Kavanagh.
All right, folks, take us to the future. Indeed, we're talking to a couple experts in the IoT space, really in the edge computing space today on Inside Analysis. We just talked for a couple minutes to Peter Norwood, and we're going to talk now to Loren Long, who's a company called DartPoints. So Loren, welcome to Inside Analysis. Tell us a bit about yourself and your company and how you're enabling edge computing.
Hey, thanks, Eric. It's great to be here, and it was a lot of fun listening to you and Peter in the last segment. So I'm one of the co-founders of DartPoints. I'm currently the chief development officer, which I'm driving the edge for our company. What is the edge to us? There's so many definitions. There's a joke going around, if you have 5 people and you ask them, you'll get 7 definitions. But our take and our view on it, and it starts, back in 2012 when we founded DartPoints, and we had all come out of the telecom space. And in the telecom space, it's all about distribution and pushing out, more antennas, more fiber, more to reduce latency, to improve performance, et cetera. And at the time, the data center industry, being, it's real estate, was all about bigger, denser, but it didn't serve the end customer. Because if you look at the whole equation, from the very highest level, it's all about the content on one side and the consumer on the other, whether the consumer is a business, a school, a family, a device now. And it's about making that connection faster. All the rest of us exist to make that faster. And, distance, it's just a law of physics. Distance, increases the time and reduces performance.
Right.
And so, our whole goal has been to push the core capabilities and specifically more around networking, and not networking, but the greater ecosystem of the network. If you look at the traffic volumes through the 6 largest cities in America, that also house the largest carrier hotels with the largest internet exchanges. It's still vastly disproportionate to where all that traffic is going, and that is an inefficient model, and it's not sustainable. We talked about the data deluge way back when, and that's it's gone far beyond what we ever thought it would. So the idea of pushing the resources out further and further toward where data is created and consumed, it helps everything. So our mission, our goal is kind of for our 4 pillars, if you will, is creating interconnection data centers in markets that aren't currently served by the same infrastructure that you find in a Chicago or a Dallas or a New York or LA, which, when you bring that purpose-built interconnection fabric with an internet exchange, with the compute, with the storage, and you allow the content and applications to move out of those big cities and towards, cities like Wichita, Kansas, and Cheyenne, Wyoming, Columbia, South Carolina. Now they can be served locally. And our mantra has always been, before an application can sit somewhere, the server has to sit somewhere, and that somewhere is a data center.
Yeah, I love that you're going to I'm looking at your cities: Asheville, North Carolina, Columbia, Columbus, Indiana, downtown Cincinnati, for example. So you're taking specific regions, you're building out very specialized units that can optimize the flow of traffic and enable this sort of next generation of applications and use cases. Is that about right?
That's exactly right. And the idea is, we're not doing anything that hasn't been done. But it's taking the same ecosystem of cloud sitting next to carriers, interconnected through a peering fabric, that exists at a CERMAC in Chicago, taking that to Eastern Iowa or Fargo, North Dakota. So it allows it to sit there, because one of the key parts when you look at the telecom networks, internet exchanges are critical. That the peering is where that exchange happens. And so if there is not peering available, content and application providers aren't going to deploy in a market if they can't reach the people in that market. There's a great analogy that we've given. For example, in the state of South Carolina, there was no internet exchange. There is now. In fact, we had a great grand opening with the governor a few months back, but I likened it to grocery shopping. You don't want to drive to Atlanta or Northern Virginia to go grocery shopping if you live in Greenville, South Carolina.
Right.
So by creating those internet exchanges, it allows the grocery store, if you will, being the internet, to now deploy, to bring the servers, to bring the content and the applications locally, because it can be peered locally. Otherwise, why would they do that if it's only going to, hairpin through Atlanta?
Yeah, that's interesting. And so are you guys, so you specialize in a number of different things, but do you work with the hardware vendors, or do you have anything to do with the hardware, or are you just a services play, or is there a hardware play too? Well,
I would say we're a services play, but I've talked about the data center and the internet exchange. There's also there's the infrastructure side of it, the servers, the high power compute, and one of the other, I guess, foundational ideas around DartPoints is this is going to be a shared environment. It's going to be a multi-tenant. It's going to be shared resources, environment, investment. And we can look at our history. If you think about cell towers, back when all this was first starting up, in the the 80s and 90s, every carrier had to put up their own cell tower, and you'd look at a hill and there'd be 4 or 5 towers. And it's like, well, that's ridiculous. right? And then all of a
That's a good
sudden,
point.
we got tower companies, and now there's a tower with 4 to 5, arrays of antennas on it. It makes sense because no one company has enough capital, especially when you're talking about the edge. Nobody can do it all.
That's interesting.
And from this, the other side of the coin, no company wants to do it all because it's all about the ecosystem. You want, the carriers want to be connected not only to Azure, but also AWS. And also, Pratexo wants to be able to connect with that ecosystem as well, and the myriad of companies that have grown up, around this. So the idea is creating a uniform, secure, compliant platform that allows these applications to be deployed. And our idea is, if you're looking at a market where there isn't a lot of technology currently, well, you're going to need the space, you're going to need the power, you're going to need the infrastructure, and you're going to need the services and resources to operate it. You're not going to want to hire that. And so it's our part of the enablement is we've got all that. Just bring your application and content and or servers, and we'll take care of the rest, as well as the interconnectivity.
Yeah, that's interesting. Well, and CDNs are such a huge part of our world today, right? Content delivery networks. Do you want to kind of talk about what role you play in enabling those folks? Because I'm guessing that's a big part of what you're doing, is it?
Yes, they're huge as well. They would get a subset for us in the ecosystem, a critical one, because they're the step between them, people finding the content, right?
I see.
Now I would say they've been distributing for years. Companies like Cloudflare and Akamai, Limelight. But the other challenge when you start, because the edge is also a scale challenge, right? It's not just, you don't just go to a factory, and I mean you can, and it works for that factory. But actually, I'm gonna change the paradigm. I'm gonna talk about farming real quick instead. Which is another area of massive technological advancement in the last few years. But talking to the CEO of we'll call it a farming equipment company, and their challenge, he said, and I'm gonna paraphrase it. I would love to be able to take advantage of edge infrastructure for my market, for my customers. But until it's ubiquitous, until I can count on it being there and being across all of my markets.
Interesting.
I can't. Why would I invest that much money in R&D for an application that's only going to live in 4 of the 79 markets where my customers live? And so that's where the responsibility, and I've kind of changed the dialogue a little bit, but it also then shifts back to companies like DartPoints and Pratexo and the rest of us that are actually building out the infrastructure of the edge to reach scale, so that the larger companies can invest in the R&D to make these applications as ubiquitous as their customers.
That's such a great point. And agriculture is a fantastic use case for IoT and for sensors, because, and I love to grow plants myself, so I'm not an expert in it, but I've been doing it for years. And whether it's vegetables or whatever, trees, etc., with sensors, you can find so much information about the soil, for example, about the amount of sunlight, about how dry your plants are. And these days, again, mixing that or blending that IT, OT, different universes, blending those universes together, now you can be much more efficient about watering your plants, about getting them the right nutrients that they need, not over fertilizing, for example. I mean, I lived in New Orleans on the Mississippi for a number of years, and there's a dead zone at the edge of the Mississippi where it goes out into the Delta, the Mississippi Delta. And that's because of fertilizer. Mostly it's because of all the fertilizer, because we over fertilize stuff. And so there are lots of sort of, no pun intended, downstream impacts of using fertilizer too much. And with these IoT technologies now, we could be much more efficient and much more precise about how we take care of our crops, right, Loren?
Listen, I mean, you can, even, whether it's, precision agriculture, which you're right, now you don't need to spray, tons and tons, because the sensors pick it up and say, there's a weed, go get it.
Right.
And that's it. And so, medical is another huge one, right? The medical advances that are allowing patients with the, technology in hand that basically brings the doctor into a house, and it could be a 2-hour drive for them to go to a doctor, but with this device, put it right here, and the doctor might as well be in the room. That's fantastic.
Right. That's right.
But that requires the technology and the infrastructure that enables that. And I think obviously a lot of the big buzz in the industry right now is the metaverse. We know, augmented reality, virtual reality is a bandwidth hog.
Yeah.
And when everybody jumps on that, there's not enough pipes right now. It has to be distributed. There's no way it can be done from a centralized standpoint.
Yeah. That's actually a really good point too, as we think about architectures and building out the solutions to make all this stuff happen. In the networking space, there are lots of, especially these days, there are lots of different things that you can do to be able to handle this sort of capacity, but it all takes effort, it all takes time, it takes computational power, et cetera. And to your point, we create new opportunities, we create new bandwidth, and then we chew it up and use it. And then we create more and we chew that up and use it. If you think about this whole concept of code bloat that my developer friends talk about, in the old days, you had to be very, very careful with your code such that it was highly performant because it was so expensive to get the compute for the storage, everything. And now, of course, you can do all kind of stuff. The processors are fast. So code gets kind of messy and unwieldy, and that's moving in the wrong direction, right? So you always do have to keep the original principles in mind as we design, but there are so many ways to get it done, right?
No, there absolutely is. And like I said, like Peter was talking about, the innovation that's out there and the companies that are spawning companies, it's fantastic to watch.
Yeah, it's a lot of fun. So who are your typical clients? I mean, how do you get out there and get the word out, being such a sort of an enabling partner ecosystem sort of player? Do you identify, key partners first, or how did you kind of roll out to market, go to market?
It's like any exchange or like any ecosystem, it takes both sides. And so from the right side, it's the content and the applications that are seeking a closer connection to their customers, and at the same time, the carriers trying to differentiate and improve their services and their offerings are trying to get closer to them. So it's bringing the two together. So it's we like to joke that sometimes the edge is the chicken and egg ranch, because there's always dependencies of dependencies, right?
Right.
But it's both sides. It's the content and applications. It's the clouds. It's the different IoT verticals that are pushing out. It's the carriers. Especially if you look at and this is from the national carriers all the way down to regional level carriers. Which would they rather use their bandwidth for? Carrying the same byte 200 miles or just 2 miles?
Right.
There's an efficiency to their network because they're the ones that are paying for all the fiber to get buried.
Yeah, that's exactly right. He reminded me of the old days when cable companies came out and laid all that cable in the suburbs, right? It was a crazy new day. Right. And of course, now Google in particular and others have rolled out fiber in a lot of these cities, and that's changing everything. I mean, I think the bottom line is no one ever wants slower internet, or connectivity. Everyone always wants better. And then when you get really good connectivity, you don't ever want to go back. Right. I saw a meme go out a while ago that said something like, if you want to get involved with someone, like, romantically, put them in front of a computer with bad internet for a couple hours to find out who you're really dealing with. I thought that was pretty dark. Nobody wants that. Everybody wants speed. You can't stand the slow stuff anymore. Can you imagine going back to the dial-up days? I don't think it's going to happen, folks. Well, look, don't touch that though. We'll be right back. You're listening to Inside Analysis.
Welcome back to Inside Analysis. Here's your host, Eric Kavanagh.
All right, folks, back here on Inside Analysis, talking to a couple of experts today. We've got Loren from DartPoints and Peter Norwood from Pratexo. And we're talking all about the edge. It's a computational revolution. It really is. Lots of fun stuff is happening. And Loren, I'll throw it back over to you just because you had such a fun story in the break there. Do you want to tell us real quick, just because it does kind of tie into networking and accessibility and pricing and customer churn and all that stuff. Tell us real quick what that was all about.
Okay, so if all the listeners remember or viewers remember the Pokemon Go craze. And, everybody walking around like zombies staring at their phones or interrupting golf games, in Peter's case. But the interesting part about that is you go back to, most of the mobile operators would compete on price. The networks were all about the same, depending on where you were. But all of a sudden, what they found is that these kids walking around with phones, if there was enough latency and jitter, it would actually induce either vertigo or nausea. And it would then cause people to go and find a better carrier so they could play their game. And it was pretty interesting from an industry standpoint that now you've got a recreational pursuit creating health concerns that's now driving churn and increasing ARPU, which it's just, I think it's a harbinger of things to come.
Yeah, it's really interesting. I'll throw it over to Peter to comment on here. All the apps that we're using, all the games that we're playing from a consumer perspective for just entertainment stuff, but also from a business perspective. I mean, I think we're at a phase right now where we're going to see more apps built out for business in 2022 than ever before. And we'll probably hit a point where it's like, 2 years will eclipse all the apps ever built, because there are so many things you can do that are specialized business apps just for your particular company and your market with your DNA. The standard off-the-shelf stuff, it doesn't really account for all that. You have to build specialized apps, and now you could do it so quickly and so robustly. That's a really big deal. What do you think, Peter?
Yeah, I think there's a good analogy with the smartphone and the app stores that powered them. You want to be able to have an application running on your phone, giving you up-to-date information. And as much as possible, it needs to operate at light speed on your phone and not be delayed trying to get information back from the cloud. And that's what's happening with the edge. We're now putting compute nodes out into the field, into the far edge, right into the manufacturing facilities, right into every floor of every building, right into little transformer stations in the field for the case of power companies, onto ships, in cars, there's computers. So you're putting all the computers out there and they're running applications. They're running AI models, sophisticated AI models, doing all that local computing out there. And so it's very analogous to the movement that happened with smartphones, with the explosion of millions of applications running on them. We're going to see more and more applications. They're going to be running on the edge. And that's a completely new paradigm. We've been so used to having companies running applications on their servers and then moving them to the cloud. This is a whole new paradigm. And it means that you've got to figure out how to do very large scale distributed network planning, push software out to the edge, keep it running even when devices are failing. When you have that many devices, something's going to go wrong. The internet may go down, everything needs to keep running. So that's the new edge paradigm. And that requires new tools. That's why there's such an explosion of new companies in space that are addressing this problem. Our particular take is make it easy to architect and design the network and push all the software out through a push button, and then leverage companies like DartPoint. There's often multi-tier networks. You have compute nodes at the far edge in the manufacturing plants, in the buildings, but then you want to send some data up to an intermediate node, some local data center, to be processed to reduce latency, and then up to the cloud for really your ROI dashboards. You don't want to have all these round trips causing the latency that Loren was talking about. You want to take, and we're not just collecting sensor data. There are actuators out there at the edge that are taking actions. You can change the operation of the infrastructure just as you can listen to it. And so you want a very short round trip for all that.
Yeah, that's an excellent point. And the other thing I'm thinking about here, and I'll throw it maybe over to Loren to comment on, and then back to Peter, is projection, understanding what the need is going to be for my product, for my service, whatever the case may be, sensors are a brilliant way to deal with that. I mean, I know there are some shopping malls in Germany, for example, that are using very sophisticated solutions to check how much traffic is coming into the city that day, to check local listings, for example, of events and things of this nature. And all that goes into an algorithm that predicts how many people will come into the mall that day. So that's a classic case of real world data at scale that you can ascertain through known channels like cell phones, like think how Waze works, for example, or how Google Maps, even when you're driving down the highway, sends you the message, oh, is there still a speed trap here, for example? I mean, these are all IoT examples. And for me, from a business perspective, especially in retail, it's really powerful for projecting how many people you need, how many resources, what products to buy. What do you think, Loren?
Even some of the newer applications that I've heard of, because now you bring in blockchain, which is another exciting area, and tracking, for example, and this is one that I learned about just 2 weeks ago, where once upon a time in a rail yard, the cars would get counted, and then of course they put little sensors, and now they know that the cars are there. Well, with once you add now RFID tags and the readers and the blockchain, you can have an entire train whipped by a pole with the data center sitting right there, full of compute and storage, that knows everything that was on that train, where it's going, when it was produced, who produced it, who it's headed for.
Isn't that wild?
And it's crazy. Another one, a retail example, which I think we start getting into some. Well, it's thought provoking. I'll put it that way. But some retail stores that are now tracking their customers. They've got the app. It's allowed, right? It's hey, I'm doing coupons. It's like, hey, I saw you were on aisle 17,
right?
Looking at crackers. Did you know we had a special on cheese on aisle 3? And really, you should go this way because they want you to go up aisle 7 because they know historically aisle 7 doesn't get as many customers, and so they're trying to drive more traffic through there because they've got a promotion on whatever.
Isn't that wild?
And I think you guys talked about it. Actually, it may have even been the pre-show, but I love the open source. I love how not to romanticize the edge, but we are challenging a lot of the ways the status quo has dictated how things are done. And
That's
as you
right.
distribute resources, and as you allow all these innovators and companies to come up with doing things that nobody else has thought of, now the infrastructure and the interconnection and the everything's there to take advantage of it.
Yeah, that's amazing stuff. And I'll throw it over to Peter to comment on here too. The thing I love about open source is that it's climbing up the stack. First of all, it started, of course, with Linux, with the operating system. Now it's climbing up the stack on the data side, on the networking side, and into the verticals, for example. And what's cool about that, lots of different things, one of which is it allows businesses to focus on the tech that is special and key for them, right? Because you want to be as optimal as you can in leveraging compute and processes, but also your people and your business model and what's possible. So if you don't have to worry about reinventing every wheel, like standing up all the servers, standing up all the operating systems, all that stuff, you can get to the real meat of what makes your business unique, right?
That's right. Yeah, I think we're seeing that more and more, that people are wanting to have an open source infrastructure that can run on any type of hardware, and then focus all their attention on the value delivery of the applications that run on top of that are really custom to their use case. I want to go back to something you said before about predicting the
60.
Predicting the size of the needs. I think what's one of the unique challenges of edge computing is that there's so much data and it's so distributed that it's difficult to figure out how you should set up a network like this. What power computer should you put at the edge? How much data are you going to need to process? So one of the things you're seeing more and more of, and that we're promoting, is the creation of a digital twin. And a digital twin is this concept where you create a version of the network that you're going to deploy, but it's a virtual network and you can deploy on virtual machines in the cloud.
Yeah, let's pick this up. Let's pick this up in the podcast bonus segment because I want to get into this, folks. If you're not getting the podcast bonus, hop online. InsideAnalysis.com is where you can find all that good stuff. Send me an email, info@InsideAnalysis.com. Podcast bonus segment coming up next. Okay, folks, time for the podcast bonus segment here. We wanted to talk about digital twins. This is a fascinating concept that we're going to hear from Peter Norwood from Pratexo that allows you to do scenario modeling. It allows you to play around and to see what might happen if we do this, if we do that. Sometimes we refer to those as Monte Carlo assessments in the financial world. But Peter, go into some detail on the digital twin from the perspective of this network architecture work.
Yeah, suppose you're planning a network architecture and you've got thousands or hundreds of thousands even of devices in the field from which you're collecting data. You want to understand what kind of processing unit to put out there at the edge next to the sensors. How powerful should it be? Should it run an AI accelerator card if you're running an AI model? How should you configure that node? How much memory should it have? Well, you can create a digital twin of the network that represents the real systems, but they're virtual systems, and you can deploy a cloud set of virtual systems and then simulate traffic as you would be getting in real life from the sensors in this digital twin that's running in the cloud, and do performance measurements. And so before you even buy any hardware, you can determine what the requirements of your network should be. Should you have a certain type of node, and how many tiers you should have in the network? This is a new kind of simulation environment that's being created that's more tuned for the needs of an edge computer network.
Yeah, and how do you get there? I mean, do you folks offer templates for that kind of thing? Because it sounds pretty complex. Do you basically just enter in, okay, we're going to have X number of devices, we're going to have this kind of setup, these technologies, you kind of build out the vision of what it will look like, and then you run your simulations on that. Is that kind of how it works?
Yeah, well, so it is complex. It's specifically what we're trying, what our product addresses by creating an architectural description of the network that you're trying to create. So we have, through a drag and drop interface, you lay out the different layers of your network and the software that's going to run through it in order to collect the data, process it, and generate your ROI dashboards in the cloud. So you have a multi-tier network that you've architected and designed through a drag and drop interface, and you created a description of that. And then from that, you can go to any of the cloud vendors and you can say, well, let's use some of the virtual machines they have that match certain system types, small, medium, large. And you can try it out on small, medium, and large virtual machines and see what the processing, if you've got bottlenecks. You can take simulated data or recorded data, play it through there, and see the end-to-end performance.
Wow, that's so cool. And that's great, because if you're going to take a big risk like that, you want to make sure that you've dotted the I's and crossed the T's. And I'll bring Loren Long in for some final comments on all this. You know, Loren, when I think about planning out what's possible in this new world, it's very exciting. But if you think about the past, we always had to worry so much about the peaks and the valleys, right? So in the old data center world, you had to have to provision for the peak, even though most of the year is going to be the valley. And that is not a fun place to be, because now you're sub-optimizing use of the hardware for 10 months out of the year or something. Well, that's no longer that big of an issue, in part because of Kubernetes, in part because of the elasticity of the cloud. And I have to think that the edge use cases are a perfect, like a poster child almost, for the need for elasticity, for the need to expand out computation when necessary, to bring it back in, to expand networking when necessary, to bring it back in when not. All that kind of stuff is really, it's going to be mission critical for hitting the price points that are the success or failure of business, right?
You just said a whole lot right there. Which part do I hit first?
It's up to you.
Yes, I would say stakeholders certainly want you to recoup the investment made. I think we're going to see an evolution, and I think it'll be faster than we've seen in the traditional core. Right now, I think as people push new things out, they need to control as many of the parameters as possible to control for performance. And so there's not a lot of shared environment going on. But
interesting.
What I think is that people are very quickly, because they are comfortable with, whether it's, sharing a blade, now to sharing a server, now we're, the infrastructure that we're building, both from a, traditional and then a two-phase liquid immersion, high power compute, it will be composable. It's built so that when somebody's ready to come in and run an application and then tear it down and run away, yeah, we know that's going to happen. The question is when.
Wow. This is just cool stuff. Well, folks, look these guys up online. Peter Norwood with Pratexo. It's Pratexo, and Loren Long from DartPoints. If you want a job, folks, just look into this space. The edge is just so amazing. It's so topographically unique and interesting. Whatever industry you're into, whatever hobbies you have, I promise you there are apps being developed. If you want them to run quickly and efficiently, you got to talk to some of these guys. And like I said, if you want to be in the show, send me an email, info@InsideAnalysis.com. This does conclude our show. We'll talk to you next time. You've been listening to Inside Analysis.